Section 6.7, dilations in the coordinate plane. We're going to dilate figures in a coordinate plane and we're going to find the scale factor of a dilation. So let's talk about what is a dilation. Well, a dilation is a transformation, and a transformation is an operation that moves a geometric figure to produce a new similar figure. And sometimes those transformations are called rigid, which means it doesn't change the size or shape. And sometimes dilations do change the size or the shape. So you've already actually talked about some other transformations in previous work. Like a translation moves the object left or right, up or down. You probably called it a slide, possibly. For short, a reflection reflects an object over a line of symmetry, and you probably called that a flip. And a rotation rotates around a given point, which would be a turn or maybe a spin. But what we're going to focus on is we're going to focus in this section on dilations, which actually enlarges or reduces the size of an object and produces a similar figure. So, a dilation is a transformation that enlarges or shrinks a figure to create a similar figure. Here are some things to note about dilations that are important. A dilation is always enlarged or reduced around a fixed point. And that fixed point is called the center of dilation. And it's important to note that when you're dilating in the coordinate plane, the fixed point will always be the origin. So in a coordinate plane, if you're on an XY axis coordinate plane, the fixed point will always be the origin, which is, of course, 0, 0. Finally, dilations enlarge or shrink by a scale factor of dilation. So the scale factor of dilation, and as you know, the scale factor in general is the ratio of sides. But when we write the scale factor in a dilation, we always describe the ratio as the dilated image compared to the pre-image. So it's always going to have the dilated come over the original. So keep that in mind. That is very important in our dilation work, because they're not going to specifically state this triangle to a different triangle or polygon. But they are going to expect you to know that you need to always write the scale factor as the dilated image compared to the original image. And here's kind of a visual of what that looks like in a coordinate plane. Again, here is the center of dilation right here at the origin 0, 0 in a coordinate plane. So in this case, ABC has been dilated, and what it became is XYZ. And the scale factor here is K. So again, it's always the scale factor is the original compared to the image. So if you write the original K compared to the side, or compared to KX, that's how you would write that. So let's talk more about dilations in the coordinate plane. To describe a dilation in the coordinate plane, you take the ordered pair that you're given. Here's your original ordered pair, and you multiply each ordered pair, each value, the x and y, by k, the scale factor. And so it becomes pretty simple. And what happens is, if your k value is less than 1, then it's going to shrink or reduce. If your k value is greater than 1, then it's going to enlarge it. And that kind of makes sense. So, in this example, I did some work for us ahead of time so that you wouldn't have to watch and wait for me to plot the pre-image, but it says draw a dilation of quadrilateral ABCD with the vertices A, B, C, and D given. And the scale factor of xy right here maps onto 1.5x, 1.5y, and we call the dilation wxyz. So it says graph the pre-image. So the pre-image is A, B, C, D. So now to calculate the dilation, we take the ordered pair A, which is going to become W, and we multiply the x value by 1.5. So 2 times 1.5 is 3, and 2 times 1.5 for the y is also 3. So my new ordered pair is 3, 3. And again, what we're using is we're using the scale factor of 1.5. That's this right here. So now when I take these other ordered pairs, I take 4 and multiply it by 1.5, and that gives me 6. I take 2 and multiply it by 1.5, and I get 3 again. And again, we can fill in the rest of these ordered pairs. I'm sure you can do that math quite easily. So now I'm going to graph the image. So W is 3, 3. Then I have 6, 3. And that is my x value. And then y is 6, 0. And z is 0, negative 3. So here is my dilated image. And what it really means is that wx, each side, will be 1.5 times bigger than the length of AB. So again, these are similar figures, so all the corresponding angles will be congruent and all of the sides will be in the same ratio. And if we write the ratio of the dilated image, so if we take this length, we can easily see that that length is 3 units long. And if we take the length of AB right here, that is easily clear to see that's 2. And if we write the dilated compared to the pre-image, that gives us a scale factor of 1.5. So hopefully you're able to see how those things are related. So now it's your turn to try. I'd like you to try this particular example where triangle ABC vertices are given, and we're going to graph the triangle image PQR, and given again that this is the transformation or the dilation, that XY goes to 0.5x, 0.5y. And notice again, your K is 0.5, so what would you expect? Is it going to be bigger or smaller? So I'd like you to try that example, and then I'd like you to check back to the notes to make sure that you are understanding and have gotten it correct. So now let's look at this in a little bit different way. This says, given ABCD, you want to create a similar figure called RSTU. What is the scale factor of ABCD to RSTU, and what are the coordinates of U? So eventually, you are going to try to find U, and you're going to use D to do that. But first, let's find the scale factor. Well, let's take an ordered pair that we do know. So we know the ordered pair A corresponds, so A is going to correspond to R, and we know that ordered pair right there. So A is the ordered pair 1, 2, and R is the ordered pair 3, 6. So intuitively, if we look at this, what would K be? Well, in order to go from 1 to 3, what are you multiplying by? In order to go from 2 to 6, what are you multiplying by? Well, you're multiplying by 3. You're multiplying by 3, so your K is equal to 3. So now we can use that information to actually find the other value. And we can see that our scale factor then is 3. And because remember, it's the dilated image compared to the original image. And so it would be 3 times bigger. And so now what we're going to do is we're going to use that information that our scale factor is 3 to take the ordered pair D, which is the one we know, and D is the ordered pair 5, 3, and we're going to use that with our scale factor of 3 to find the missing ordered pair that we are trying to find U. So if I multiply 5 times our scale factor of 3, I get 15. And if I multiply 3 times our scale factor, I get 9. So that is the ordered pair for U. And in this next example, we are going to find the scale factor of just a word problem where we're not going to have the picture and it's not necessarily in the coordinate plane, but the ideas are the same. So it says you are using a photo quality printer to enlarge a digital picture. The picture on the computer screen is 6 centimeters by 6 centimeters. The printed image is 15 by 15. What is the scale factor? So again, whenever we are writing the scale factor, it equals the dilated compared to the original. So the one on the computer screen is the original, and the printed image is the dilated image. So we have 15 over 6, which is 5 over 2. Or you could say that that equals 2.5. And that is the end of section 6.